Reports say American B-2 stealth bombers left the U.S. and appeared to be heading towards Diego Garcia, a strategic military base in the Indian Ocean. This comes as Israel-Iran war enters the second week.
When you first lay eyes on the B-2 Spirit bomber, it immediately looks unlike any other aircraft. You might notice something unusual. 'Tis missing a tail. There's no vertical stabilizer, no rudder, not even a fin. This is not a mistake or a futuristic aesthetic choice. It's a carefully engineered feature at the heart of the B-2's invisibility. The absence of a tail isn't just a quirk of design, it's the first clue in understanding how the B-2 Spirit became the most elusive, radar-evading bomber in military history. The shape of invisibility. The B-2 was not created to dominate the skies through speed or aerobatics. Its main mission is much simpler and more sinister: to go unseen. Everything about its design, from its curved body to the smooth lines and seamless surface, was developed to avoid detection. Traditional aircraft reflect radar waves due to their sharp edges and upright tail sections. The B-2 does the opposite. Its tailless, swooping silhouette is made to scatter radar signals away in all directions, rather than bouncing them back to the source. This allows the bomber to slip through heavily guarded airspace without alerting enemy defenses. The missing tail is not a liability. It's a strategic advantage. Flying without a tail. A tail on a conventional aircraft provides stability, acting like the feathers on an arrow. It helps the plane maintain direction, balance in flight, and enables precise steering. Removing the tail might make the aircraft more stealthy, but it also creates serious aerodynamic challenges. Without stabilizing fins and control surfaces at the rear, a plane becomes naturally unstable and extremely difficult to fly. Most planes would tumble or spin uncontrollably. So, how does the B-2 stay in the air? The answer lies in advanced digital flight systems. The flying wing concept. To minimize radar detection, Northrop Grumman engineers embraced the idea of a flying wing, a design in which the aircraft is essentially just a wing, with no protruding fuselage or tail. This shape reduces drag and improves lift, but it also presents immense control challenges. The concept of flying wings dates back to the 1940s, pioneered by Jack Northrop, who built experimental aircraft like the YB-35 and YB-49. Those planes looked futuristic, but the technology needed to fly them safely didn't exist yet. They were unstable and uncontrollable. By the 1980s, however, digital flight control systems had matured enough to make the flying wing concept viable. The B-2 became the first operational bomber to successfully use this design, marrying low radar visibility with a revolutionary shape. Why the B-2 should not be able to fly? The B-2's stealth-focused shape makes it so aerodynamically unstable that it should be unflyable, at least by human pilots alone. That's why the aircraft relies entirely on computers to keep it in the air. The B-2 uses a fly-by-wire system, meaning the pilot's commands don't directly move control surfaces. Instead, inputs go through a central flight computer, which interprets the desired motion and then tells motors and actuators what to adjust. This system makes thousands of micro-adjustments every second to maintain stability and direction. Without it, the bomber would quickly spiral out of control. The aircraft uses specialized surfaces like elevons, which combine the functions of elevators and ailerons to manage pitch and roll. For yaw control, instead of a rudder, it uses split rudders panels that open like clamshells on either side of the wing to create drag and shift direction. Spoilers help the B-2 turn by disrupting airflow over one wing. Even its engines contribute to control, with differential thrust used to help steer. All these functions are handled by onboard systems, leaving the pilot to focus on mission strategy while the software keeps the bomber stable in flight. What makes the B-2 so unique? The B-2 Spirit is not just another military aircraft, it's a technological leap ahead of its time. First flown in the late 1980s and officially entering service in 1997, the B-2 was created with one goal: to penetrate enemy airspace undetected and deliver devastating payloads. It was conceived during the Cold War as a response to increasingly advanced Soviet air defenses. Even today, its capabilities remain unmatched. The B-2 has an impressive wingspan of 52 meters and can fly more than 6,000 nautical miles without refueling. With the help of mid-air tankers, it can exceed 10,000 miles in a single mission. Despite its large size, it is remarkably quiet and difficult to detect. It can carry up to 40,000 pounds of weapons, including conventional bombs, smart munitions, and even nuclear warheads. Its stealthy approach allows it to fly directly over targets without being picked up by radar. This makes it ideal for striking heavily defended positions like underground bunkers, mobile missile platforms, or enemy command centers. How the B-2 stays hidden. The B-2's stealth is achieved through a combination of shape, materials, and smart engineering. Its smooth, tailless body avoids the angular surfaces that typically reflect radar. It is coated in radar-absorbent material which soaks up electromagnetic waves and further reduces its radar signature. The aircraft's engines are hidden deep inside the wing, and their exhaust is carefully cooled to minimize infrared detection. Even small details, like perfectly sealed panel lines and hidden seams, contribute to its low visibility. To maintain this delicate balance, the B-2 is stored in climate-controlled hangars. Dust, moisture, and environmental wear can damage the ram coating or create imperfections that make the aircraft more visible to radar. After every mission, it undergoes rigorous inspections and maintenance to ensure its surfaces remain flawless. That kind of upkeep doesn't come cheap or easy. A high cost of stealth. Each B-2 bomber came with a staggering price tag of around $2.1 billion. But the costs don't stop at production. Maintaining one is akin to servicing a high-performance space vehicle. Every flight requires hours of maintenance. The stealth coating must be checked and often reapplied. Sensors need recalibration, and every panel is inspected for alignment. There is no room for error, just a slight defect can make the aircraft more visible to enemy systems. On top of that, the B-2 has no manual backup flight controls. If the fly-by-wire system fails, the plane becomes essentially unflyable. This makes it highly dependent on its software, which must be constantly updated and tested. Its invisibility is what gives it its edge, but it's also what makes it so fragile. Limitations of the B-2. While the B-2 excels at stealth, it's not without its limitations. It's a subsonic aircraft, cruising at about 630 miles per hour, which is slower than many modern fighters and even older bombers like the B-1 Lancer. It lacks maneuverability and is not built for close-range combat. If discovered, the B-2 has no onboard weapons for defense, no missiles, no guns. Its only protection is its invisibility, along with decoys and electronic countermeasures. Visibility is another challenge. While radar can't easily spot the B-2, human eyes still can, especially during daylight missions. That's why most operations are conducted at night or in cloudy conditions. The bomber usually flies with extensive support from tankers, satellites, and reconnaissance drones to ensure its mission remains undetected and unchallenged. The arrival of the B-21 Raider. As revolutionary as the B-2 has been, it's not the final chapter. Its successor, the B-21 Raider, has already begun flight testing and represents the next generation of stealth bombers. Officially unveiled in 2022 and developed by Northrop Grumman, the B-21 shares many design elements with the B-2, including the flying wing shape and tailless structure. But under the surface, it's built with modern warfare in mind. The B-21 is designed to be cheaper, more maintainable, and more adaptable. It uses modular systems and materials that simplify repairs and reduce upkeep time. It is built for larger production runs, with the U.S. Air Force planning to purchase at least 100 units, far more than the 21 B-2s originally produced. It's tailored for future conflicts, with advanced survivability features, networked warfare capabilities, and improved stealth to counter evolving threats from countries like China and Russia. And there you have it, the incredible journey from the Concorde to Boom Supersonic's Overture. If you're just as excited about the return of supersonic travel as we are, smash that like and hit that subscribe button. Thanks for flying with us today, and until next time, keep dreaming big, flying high, and chasing that sonic boom.